In this video, we're going to talk about double replacement reactions and how to determine whether or not a double replacement reaction will occur. So just like in single replacements, just because you put two ionic compounds together for a double replacement doesn't necessarily mean it's going to happen. So when we do double replacements, and you're going to do many of them in the lab, and you probably have already done some, they typically happen in an aqueous solution. So basically what we do is we dissolve ionic compounds in water, and then we put them together, and then we see whether or not a reaction occurs. So when something dissolves in water, when an ionic compound dissolves in water, we say that it dissociates, or it separates into its cations or anions. So just to give you an example or show you what that means, if you were to put sodium chloride into water, right? So here's a cup of water, and you have, your polar water molecules in there. Let me make this a little bit bigger so you can see it. You've got you've got the negative side and the positive side. And if you were to put sodium chloride in, remember that it is a combination of positive and negative anions. When you put it in here, the sodium is attracted to the negative side of the water, and the chloride is attracted to the positive side of the water, and that is what dissociation is. It separates into its parts. So essentially, an aqueous solution is basically a soup of all these ions sort of floating around, dissolved in the water. So, in a double replacement reaction of this type, they will only happen if when you dissolve two ionic compounds or put them together in aqueous solution, that one of the products that is formed is insoluble in water or is not able to dissolve in water, and therefore forms a solid, which we call a precipitate. And that's why formation of a precipitate is an indicator of a chemical reaction. So what we need to do to determine whether or not a double replacement of the reaction of this type, if that happens or not, is to determine if a product is soluble or insoluble in water. And in a second, I'll show you how to do that using your reference tables. Now, there's another type of double replacement reaction that does always occur, and it is between an acid and a base. And acids and bases neutralize one another in order to form water and some salt or ionic compound. So remember, if you see a double replacement that has an acid starting with an H and a base typically ending in an OH, they're always going to react to form water and a salt. And we'll go more into detail about that type of double replacement when we get into our units on acids and bases and talk about what that neutralization actually means. So let's go back to A. So does the reaction happen by determining whether or not there is a precipitate? So now I'm going to jump over to the Almo, and we'll go ahead and take a look at some examples of those. Okay, so here I have three different reactions, and we're going to determine whether or not they occur by whether or not they form an insoluble product or a precipitate. And how we're going to do this is by using the reference tables. So on the same chart as we have the list of the 5 different types of reactions, so note the formation of a precipitate down here in the acid base, so everything I just talked about is right here in your reference tables, plus the form. So remember that double replacements are when they actually swap buddies, so they swap partners. So on the top of this page are actually what we call the soluble rules. So these will tell us whether or not an ionic compound is soluble or insoluble in water. Insoluble means that it is a precipitate, and we have to have at least one product be insoluble in order for the reaction to have happened. Otherwise, no precipitate is formed, and so there is no evidence of a chemical reaction. And essentially what we have is just a soup of ions floating around, and nothing is really going on. So if we look at the first one, so we have aluminum iodide and that's mercury chloride. So keep in mind that we need to first figure out what the products would be, and then determine if one of the products is insoluble or not. So first thing I have to do is I have to swap these guys partners. So aluminum will go with the chloride, so that's AlCl3 because of their charges. It's very important that we pay attention to the charges when writing ionic compounds. If we look here, mercury in this case is a +2, so mercury would go with the iodide, and it would be, Hgi2. So now I need to determine that one of my products is actually insoluble. So let's start with aluminum chloride. So the solubility rules say that all chlorides are soluble, except ones that have silver, lead, or mercury. So all chlorides are soluble. Aluminum is not silver, lead, or mercury, so this would be soluble. Okay. Now if I look at mercury iodide, that's in the same place here. So it says all iodides are soluble except ones with silver, lead, and mercury. So that means that mercury iodide would be considered insoluble. So we put an I, and this right here is actually our solid precipitate. So once we have found a precipitate, we can say, yes, the reaction happens. When I put these two things together, I form a precipitate and I see evidence of a chemical reaction, and then I can just go back and balance. So it's 2, 3, 2, 3. All right, let's try another one. So this one is silver nitrate and potassium phosphate. So again, we're going to swap partners. So silver goes with phosphate. Remember that silver is a +1, so it's Ag3PO4 plus, and then we've got potassium with nitrate, KNO3, they're each ones. So then we need to see, is there a precipitate in this case? So if we go ahead...
Ben Golson, please report to Mr. Pullman in the principal's office. Ben Golson, please report to Mr. Pullman in the principal's office.
So if we go ahead and we have silver nitrate, or sorry, not silver, silver phosphate here. We're looking at the products. And I'm going to go through and I'm going to find the phosphates. And I see that over here it says insoluble. All phosphates are insoluble except ones that have group 1 or ammonium. So we know that silver is not in the first column of the periodic table, and it's definitely not ammonium. So yes, this is an insoluble product. I know that this is going to be a precipitate, and this reaction is going to happen. So I could stop there, but let's just go ahead and look at potassium nitrate. So if we look over here, it says all nitrates are soluble. So this would be a soluble product. So this would be aqueous. It would be in solution. Okay. So this reaction definitely does happen. Then I could go back and balance, which I think I just need a 3 here and a 3 here. And I'm good. Alright, so let's do one last one, and then we'll talk about combustion reactions quick, and then you can practice these on your own. So here we have copper bromide and aluminum chloride. So let's swap partners. That would be CuCl2, because copper is a +2 in this case, plus aluminum bromide, AlBr3. And if I look here, I see copper chloride. All chlorides are soluble except silver, lead, and mercury. So that means that this one is going to be soluble in water. And then I've got aluminum bromide, and again, all bromides are soluble except silver, lead, and mercury. So this is soluble. So I have 2 soluble products. So in this case, this is where I'd cross these out, and I would say that no reaction occurs. Okay? So there are plenty of practice problems. There are plenty of practice problems on the Moodle, and I've actually uploaded a sheet that looks something like this with an answer key if you want extra practice other than what I'm requiring you to do for class. Okay, so the last thing we've got to talk about are combustion reactions. And combustion reactions are very simple. They are also in your reference tables. And let's see if I can get back down here to the PowerPoint. So the combustion reactions, remember, are always a combination of a hydrocarbon or a carbohydrate and oxygen. And the products we always know are going to be carbon dioxide and water. Okay? So these are how to predict all 5 types of reactions. And you'll be working on doing this in class on both the classwork and in the lab.